We now come to section 3, conventions for quotes and calculations. There are several subsections and we will go through all of them. Section 3.1, flat price, accrued interest and the full price. I'll read the definition and then give a basic explanation. When a bond is between coupon payment dates, its price has two parts, the flat price and the accrued interest. The sum of the parts is the full price, which is also called the invoice or dirty price. The flat price is the full price minus the accrued interest, and this is also the quoted or clean price. Let us understand this through a very simple example. Let's say that on day 0 you buy a 2-year bond which makes a coupon payment at the end of every year. Let's say that at the end of year 1 the coupon payment is 10, at the end of year 2 the coupon payment is 10 and the par value of 100 is returned. Now halfway through year 1 you sell the bond, and say you sell the bond to party B. The question is, how much will you sell the bond for? If you think about it, you have held the bond for half a year. During this half a year you have accrued some interest. The accrued interest is 10 multiplied by 0.5. Why? Because you have held the bond for half the year, so you actually deserve half of this payment. The way this transaction works, when you actually sell the bond, party B is going to give you 5 out of these $10. The reason is it doesn't make sense to wait till this point when the coupon is actually given to B and then you need to go track B down and get your $5. Over here we know that you have earned these $5. So on settlement date, the amount of money that you get for selling the bond should include the $5. So that's why the invoice amount will include the 5, that is the accrued interest. The amount that you pay without the accrued interest is called the clean price or the flat price, and that is the amount that is quoted. This will make more sense when we go through the example on the next slide. But at this stage, let us take a look at the calculation for accrued interest. The formula in the curriculum is very straightforward. It is shown as T divided by big T into payment. In my example, payment is this coupon payment which is 10. T or small t is the time since the last coupon payment till settlement date. This here is settlement date, and big T represents the total time between coupon payments. Notice that T, small t over big T simply represents the fraction of time that you held the bond. Once you understand this point, you can also see why the price that is quoted is the flat price. If the full price were quoted, then the price would change every day because accrued interest would be changing every day. And this should be obvious, but I'll just put the formula down here also. The full price is equal to the flat price plus the accrued interest. So if this is what were quoted, we know that accrued interest is changing every day because this number is changing. So the price would just change every day, and that would be somewhat confusing. This price would change even if the yield is not changing. Next point. We come back to this formula and look at two conventions that are often used. One convention is called the actual convention. Here the small t and the big T are based on the actual number of days, which will include weekends and holidays. The other convention is called the 30-360 convention, which assumes 360 days in a year and assumes that every month has 30 days. Now let's take a look at example 5, which will illustrate this concept. A 6% German corporate bond is priced for settlement on 18th June 2005. The bond makes semi-annual coupon payments on 19th March and 19th September. The bond matures in 2026. The corporate bond uses the 30-360 day convention for accrued interest. We need to calculate the full price, accrued interest, and flat price with this par value for different YTMs. Let us draw this out first. The coupon dates are 19th March and 19th September. The settlement date is 18th June. So if this is March, April, May, June. So we can see this is roughly in the middle of the coupon period. So this is 18th June. I'll walk you through the 4-step procedure given in the curriculum. The first thing you need to do is come up with the present value on this date. This is the coupon date before settlement date. The curriculum does this using present value calculations, which would be tedious. I want you to use the calculator. We know that N is 23 because from here 19th March 2015 till September 2026 we have 11.5 years, and since this is a semi-annual bond, 11.5 years means 23 periods. So N is 23. We are using an annual YTM of 5.8%, which means that the semi-annual number is 5.8 divided by 2, which is 2.9%. The semi-annual coupon payment is 3 because the coupon rate is 6%, and the future value is 100. That is the par value based on which we are doing our calculations. Plug in the numbers and you will get a present value of 101.66. This is the present value over here. And notice that on this date there is no accrued interest. As we move from this date to 18th June, interest accrues. So we need to figure out the number of days. That is equal to 89. And since we are using the 30-360 day convention, this is how you come up with 89. We are going from 19th March to 18th June. 30-360 means that we assume 30 days per month. Between 19th March and the end of March, we have 11 days. April and May are 30 and 30. And then 18th June means that we have 18 days in June. Add these numbers and you get 89. So this is 89 days. Step 2 is to figure out the full price here on 18th June. That full price is equal to 101.66, which is what we just calculated, into 1.029. That is the yield raised to the power of this period in years. So this period in years is simply 89 over
180.
That gives us 103.11. That is our full price. The accrued interest is 89 over
180
multiplied by 3, which is 1.48. So the flat price or the quoted price then is 103.11, the full price minus the accrued interest, which gives us 101.63. This is the flat price on 18th June. You need to know this process. This is what is used in the curriculum, but I'm also going to give you a shortcut method. You can use the financial calculator to directly come up with the flat price over here. This period is 91 days, which means that the time from here, settlement date till maturity, is 22 and 91 over 180. So you can convert this into a decimal and plug into your calculator. The calculator does take a decimal number for n. The rest of the inputs are the same. Interest rate is 2.9%, payment is 3, FV is 100. When you compute the PV, you will get 101.65, which is almost exactly the same as what you calculated through this much longer method. At the second decimal place, there is a small difference. The reason is that the market convention uses accrued interest this way. The accrued interest is based on a simple fraction, whereas the calculator uses proper time value of money calculations with exponents. So that explains the subtle difference. But if you are in a hurry on the exam, then this method will give you almost the exact answer. You can look at your options in the question, and if the options are not extremely close to each other, then you can actually use this method. Matrix pricing. Some bonds are not actively traded, so we don't have a market price or a YTM. So we can use matrix pricing to come up with that price. If the market price for a bond is not available, estimate the market discount rate and price based on the quoted or flat prices of more frequently traded comparable bonds. These comparable bonds have similar times to maturity, similar coupon rates, and the same credit quality. Let us understand the process using the data given here. We want to come up with the price and the YTM for bond X, and we have several other bonds with similar credit quality. The coupon rate is not exactly the same for the other bonds, but the numbers are somewhat close, and the maturities are also roughly in the same ballpark. We have a logical 5-step process to come up with the price and then the YTM. The first thing that you need to do is come up with the YTMs based on the price, and that is already given. If you consider this bond, 2-year bond, 3% coupon, based on this price you can come up with the YTM. Similarly, for the other bonds given, you can come up with the YTM using the price. The second thing to do is come up with the average yield for the 2-year bonds. We have these 2-year bonds. The yield for this bond is 3.786%, and this is the yield for the 5% bond. Take an average these two numbers and you will get 3.80%. Then you come up with the average for the 5-year bonds. Using these two numbers, take an average of 4.181 and 4.189, and what you should get is 4.19%. I'm rounding to 2 decimal places. The curriculum actually does 3, but 2 is good enough to explain the concept. The next thing to do is linear interpolation, and you studied this in statistics. Let me just explain what's going on. We want the yield for a 3-year bond, but we have the yields for 2-year bonds and 5-year bonds. So here is what's going on. If we have yields on the y-axis and maturity on the x, the 2-year bonds have a yield of 3.80. The 5-year bonds have an average yield of 4.19. Linear interpolation means that we make a linear line connecting these two, and then a 3-year bond would be over here. So we are after this number. The curriculum gives a formula which is simple to understand once you have this picture in front of you. This yield for the 3-year bond is simply equal to 3.80 plus, and then notice this distance is 1/3 of the total distance between 2 and 5. So we have 1/3 multiplied by this distance, which is 4.19 minus 3.80. When you do the calculation, you should get 3.93. So the YTM on bond X based on linear interpolation is 3.93. Once you have the YTM, then you can easily compute the price, and we've done this enough times. I would want you to use the financial calculator. So what are the inputs? Here is what you do. N is equal to 6 because we have a 3-year bond and this is a semi-annual bond. The interest rate is 3.93 over 2 because this is the interest rate for a year. We need to de-annualize, so divided by 2. Payment is 2 because the coupon rate is 4% per year. Every 6 months the coupon payment is 2. Assuming a par value of 100, plug in these numbers and you get a PV of 100.191. So this is the process. It looks long, but it is fairly straightforward. All we are doing is taking numbers from comparable bonds and using those numbers to come up with the best estimate for bond X. Let us do example 6, which will illustrate this concept. In this question, we are dealing with annual coupon bonds, and I have summarized the data over here. We have a 3-year bond where the coupon rate is given, the price is given. The 4-year bond is the bond which is not traded, so we need to figure out the price for this particular bond. That is the question. And then we also have a 5-year bond which is traded, so we do have the market price. Step 1 is to come up with the YTMs for the traded bonds, and this is fairly straightforward. We have done this earlier. Given that the bonds are annual, we use N is equal to 3 for the 3-year bond. The interest rate is what we need to figure out. PV is minus 107.5, that's the price. Payment is 5.5, that's the annual coupon rate, and future value is 100. When you plug in the numbers, you should get an interest rate of 2.86. This is the YTM for the 3-year bond. Use the same procedure to come up with the YTM for the 5-year bond. That is 3.45. The YTM for the 4-year bond is simply the average of these two numbers. Notice that 4 is exactly in between 3 and 5. So this is a very simple linear interpolation. The YTM for the 4-year bond is 3.15. Once you have the YTM, you can come up with the price. N is equal to 4 because this is a 4-year bond. The interest rate is 3.15. Payment is 4.5, which is the coupon rate. FV is 0. Compute PV and you will get minus 104.99. The correct answer therefore is this. Remember, the minus is just the way the calculator works. Given that you put in positive numbers for payment and FV, the calculator will give you a minus. We have gone over this before. The correct answer is that the price is closest to 104.99. Just as a general point, in case you wonder whether to work in 2 decimal places or 3 decimal places, when you see that the answers are different enough at the second decimal place, then it is okay to work in 2 decimal places. If the second decimal places were similar, then you would have to work in 3 decimal places. I'll just make a few more points on matrix pricing before we go to the next section. Matrix pricing is used when underwriting new bonds to get an estimate of the required yield spread over the benchmark. So this should be obvious. With a new bond, we don't have a market price, obviously, so matrix pricing can be used. Now, what does this term mean? Required yield spread over the benchmark rate. The benchmark rate could be LIBOR, or it could be the rate on a government bond which is similar. Let's say a government bond with the same maturity and the same coupon rate. Let's say that a comparable government bond has a YTM of 2%, and with the matrix pricing method that we just used, we get a YTM of 2.20%. This means that the yield spread over the benchmark is 0.20%, but this is expressed as basis points, and in basis points, 0.20% would be 20 basis points. So we can say that the required yield spread over the benchmark is 20 basis points. You might also hear the following expression, term structure of credit spreads. Generally, most of this difference of 20 basis points between the YTM on the corporate bond and the YTM on a comparable government bond is because of the credit risk associated with the corporate bond. And we therefore use this expression, the term structure of credit spreads. In a later section, we'll talk about term structure in more detail, but very briefly, this refers to the different credit spreads depending on the maturity of the corporate bond.